Hello and welcome to Lecture 6. This time around we're going to be talking about raw images. To introduce that concept of raw images, we'll cover a few other things first. We'll review bit depth, which we've discussed before, dynamic range, parametric editing, metadata, and finally we'll get to raw. So if you've been shooting photos for a while maybe, or you should do a lot of editing in Lightroom, some of these concepts might be familiar to you already. If not, don't worry. We're not going to get too far in depth on this stuff, but just a little bit of review. So bit depth, to recap, is where we have a certain amount of information per pixel in our images. The graphic on the top illustrates a 1-bit image or graphic on the left and an 8-bit graphic or image or photo or whatever, zoomed in obviously on the right-hand side. A 1-bit image means that every single pixel is represented by a single bit of data, a 1 or a 0, which means that it only has the capability of reproducing as a black or a white. Not able to get a whole lot of detail and color and tones with that and everything else. It's pretty limiting. An 8-bit image has many more possible combinations of 1s and 0s because there are 8 bits per pixel. That means we can come up with up to 255 levels of brightness or grayscale values to define each pixel. So in a grayscale image, we have 255 shades of gray available. The graphic on the bottom, the very bottom, illustrates an 8-bit grayscale gradient. It's pretty smooth. We have 255 levels there. And unless you look in pretty close, you're not going to be able to distinguish the individual transitions from one shade to the next over the whole 255. If you look closely, you can on a good monitor at the original file, but over YouTube streaming, I'm not sure if it's going to pick it up. The image above that is just a fake image that I made to illustrate what happens when you don't have enough levels of gray to smoothly transition between the steps of a gradient. A gradient's an easy place to see where your bit depth starts to break down a little bit, so that's why I use this. There are 16 steps actually in this gradient on top, and the black start to kind of chunk together. The white definitely group together into one band. And you can see the individual steps. If we were to increase exponentially the number of steps in there, they become so small that they're indistinguishable. So when we talk about bit depth, images with higher bit depth, for example, a 10-bit, a 12-bit, a 14-bit, 16, 32, whatever, have much, much higher possible combinations of 1s and 0s. That's all it boils down to. 14-bit is 16,384 levels that you can come up with in a grayscale 14-bit image. That's a lot of really fine gradation in between those tones. So anyways, this is just grayscale. Obviously, hopefully you guys have intuited already that this applies to color as well. So an 8-bit color image means there's 8 bits per channel, which equals 24 bits per pixel, red, green, and blue being the case. A 14-bit color image is, 14-bit times, 16,384 times 3. So anyways, it gets to be quite a lot. Don't check my math on that. I might be wrong. That's not the point. There's a whole lot. That's what I want you to get out of this. So higher bit depth gives us more data to work with. And I'll show you on the next screen why that matters. So dynamic range is a concept that, again, you might be unfamiliar with it. However, if you have a modern cell phone and you look at your settings, you probably have an option called HDR. That stands for high dynamic range. And we'll get into in a second what that means. But if you see the pictures on the right, that may look kind of familiar to you when you're using that setting on your phone. If you turn that off and you take a photo of a bright scene, the areas that are dark are going to turn to just black. There's not going to be any detail captured in that. Or vice versa. If you tap your phone to expose on some of the darker areas, then the brighter areas are going to just go to white. They're going to blow out. There won't be any detail left. If you turn on the HDR mode, then what you get is more like the image on the bottom, where the brightness values still have lots of detail and gradation in the tones, and the dark values also aren't completely blocked out or blacked out as well. So dynamic range is being increased when you turn on the HDR mode. So what's going on there is a couple of things. So first off, ignore what I just said about phones, because we're not going to really talk about phones. I just pointed that out because you might be familiar with that scenario. What these example images are is an 8-bit image versus a higher bit depth image. So you're seeing that there is detail captured in the darkest areas of that image as well as the brightest areas of the image on the bottom. On the top image, we're losing a lot of detail in the darker areas in this particular photo because it was set to expose for the bright clouds up above. Dynamic range is simply the difference between brightest and darkest measurable light intensities in a scene. Lots of scenes have greater contrast or more difference between those bright and darkest areas than what your camera is capable of capturing. So your camera's dynamic range is a lot smaller than what your eye's dynamic range is. We look at a scene like that and we have no trouble seeing detail in the shadows and seeing the clouds at the same time. Our eyes can handle that. If you're willing to get really technical in this, take GIT 384. For the first couple of weeks, we'll really go over this stuff in depth. But anyway, for our classes, hopefully what I've just explained to you makes sense. Dynamic range is simply how much information regarding brightness and darks can be captured in a single image or reproduced in a single image. And an 8-bit image simply just doesn't have enough data available because it's not a high bit depth image to do a whole lot with that. Higher bit depths means there's more data. That means that those shadows are going to have more image information in them, and you can recover that in post-processing. So let's look at a couple ways to do that. One, and primarily as far as what we're going to talk about in this class, is Adobe Camera Raw. So Adobe Camera Raw, or ACR, is a plugin for Photoshop. It's not a standalone program. If you want to look at a standalone program that does the exact same thing, then try out Adobe Lightroom. That's a much smoother designed program that stands on its own 2 feet and does all the same things using all the same tools as Adobe Camera Raw does, but it does a lot more. And we are not going to talk about Lightroom in here, but if you're into photography and you want to do a lot of photography, then I highly recommend learning about Lightroom. Again, take GIT 384 for that one, or 334, we also talk about it in there. Okay, so the basics of parametric editing are that you're simply modifying parameters, or you're creating a set of instructions that say, I'm not actually changing the pixels of this photo, I'm just creating a set of instructions so that when I hit open or render or save, I'm going to save out a copy of this image using these parameters. So if you look at the right hand side of that image, you see there's temperature and tint, exposure, contrast, highlight, shadows, white, blacks, and so on and so forth. And there's a whole bunch of tabs that go all the way across here. All those parameters can be modified, and you see on the screen on the display exactly what's happening when you do that. That's just a preview because parametric editing is completely non-destructive. It doesn't actually alter any of the files. It just creates a set of instructions that go in a little sidecar file in metadata, and those instructions say display on the screen a JPEG preview of what it would look like were these instructions to be applied. And then once you actually do apply them, you still have your original raw file intact, or whatever type of file it is that you're editing with your parametric editor. And whatever is exported out of that is another copy that is just pixels with all those edits baked into it. It no longer has a set of instructions that can be modified after the fact. So great way to work. I highly recommend looking into parametric editing. Again, if you're going to do photography, use Lightroom. That's the way it works. And there's tons of tutorials and stuff everywhere you can find about lynda.com and on lynda.com or on adobe.com that instruct you on how to use Lightroom. Okay, so metadata is, let's look at the dictionary definition here, a set of data that describes and gives information about other data. So all of our digital informations are just composed of data. So really any data that describes that is metadata. There are all kinds of metadata though. So specifically when we're talking about image metadata, we have EXIF, that's one kind. That comes from camera files. It stands for Exchangeable Image File Format. Not that you need to know that too much, but that's what it is. So EXIF is going to have all your camera information. Typically, it's going to store information directly from your camera that says, for example, what lens was used, what focal length was that lens at, did the flash fire or did it not, what white balance was used. It's going to have all kinds of information like that. It just tells about the specifics of the camera and how the photo was taken. What was the shutter speed, what was the aperture, and all those kind of things. So that's EXIF. XMP, Extensible Metadata Platform. If you Google that, Adobe comes up in the top of the list in the results, and that might tell you something about this file format. It's a platform of metadata that also includes other things, such as all those sets of instructions that we talked about in parametric editing. That's a big part of Extensible Metadata Platform, or XMP. So whenever we do some edits in Adobe Camera Raw to a RAW file or in Lightroom or whatever else, it's going to create all those instructions in the XMP format. And they're going to be stored in a separate file. So when I adjust a RAW file from a Canon camera or a Nikon or whatever else, you'll notice that on your hard drive, this other little XMP file, .xmp is the file extension, will show up, and that's going to have all the stuff inside of it. You don't really need to open that up or do anything with it, but don't make the mistake that when I first started working with RAW photos in Adobe Camera Raw, I would edit a whole batch of these, and then I would look at my hard drive and say, oh, there's all this clutter on there. There's all these extra files, and I don't know what they're for. So I deleted this whole big batch of XMP files, thinking, for whatever reason, I didn't want them there. And then I went back to my photos, and all of my edits were gone. Because when you're editing in a parametric editor, you're doing non-destructive editing like that. It's destructive only when you throw away your XMP files, because then that's where all your work is stored. That's where all your edits are, is in those sets of instructions. Okay, so there are different types of info that are stored in those metadata file formats. Camera data we talked about, GPS data can go in there too. So most of your cell phones have this functionality, whether you have it turned on or not. It's going to store the GPS data. Copyright information can be added. Captions, audio and video data. Your Photoshop edit history, this is a helpful thing to do. I believe we talked about this when going over preferences in Photoshop, but if not, take a look at your preference settings and you can turn on or off your history log, and that's going to save your edit history of all the steps that you do on a file. And you can go back and access that either in an external text document or embedded in the Photoshop document itself. There's also a format for IPTC. This stands for, again, not that you need to know it, but just in case you're curious, International Telecommunications Press Council. That's a standards body for news media, which means they try to standardize the communication formats and instructions for handling video and photos and things that are used in journalism and media communication. All right. Photo metadata, getting a little bit more specific in this, I have a screenshot below that shows you a section of the file info window in Photoshop. So when you're in Photoshop, you have a document open. Try this out with a photograph, that hasn't been edited heavily, something you didn't download from the internet, maybe something from your own camera, just so that you're able to see some of this stuff. You can look at it in a bridge too, but I just tried it out in Photoshop. Go to File, down to File Info, and you'll get this window that pops up, and it has all these different tabs: Basic, Camera Data, Origin, IPTC, and so on. That's all metadata that allows information to be transported along with your image file. It describes your data, and it works across multiple applications and platforms, which is the important thing, and that's the whole purpose of it. So, two places that your metadata goes. One is in those sidecar files that I told you about, the XMP. That is one that you can lose. It can get deleted. You can have operator error or ID10T error. If you don't know what that is, look it up. And you can remove those metadata files, and then you're in trouble because all your work's gone. You still have the originals, but all the effort that you put into it is gone. The other safer way is for the metadata to be embedded internally inside the file. Certain file formats support that. JPEG and TIFF, for example. I don't have it on here, but another real big consideration with RAW files, we'll talk about probably on the next slide, is DNG files. So embedding that metadata within the file internally is handy. It's nice. It's convenient. It keeps you from seeing all this clutter on your hard drive. Not that those files actually take up much space. It's not an issue. But anyway, those are the two kinds. So if you hear somebody say sidecar file, or if I bring that up at some point, or you see it in an assignment or in your reading, you know what that's talking about now, right? That's the set of instructions that show all the edits and information about the image itself. There are three main categories or types of metadata regarding photos. There's the administrative type, and that's going to identify the creator, the date, location, contact information, licensing information, technical details, things like that that have to do with your image. This is entered by the user. There's descriptive information, and that's again entered by the user. That's going to be including things like the headline, title, captions, keywords, text or codes that are searchable in databases and things like that. Rights section, again, this is entered by the user. This is things like your copyright information, model license agreements, model releases, location agreements, property agreements, things like that. So usage terms, for example, all those kind of things. Think back to when we talked at the beginning of class about intellectual property and copyright. So communicating that information about copyright is important. And IPTC information such as this is one way that that is communicated and can be embedded and stored along with your file. Okay, finally, we are getting to raw images. So let's talk about this a little bit. This doesn't apply to every single file. It's not something that you're going to do to an image to get better quality, for example. You can't take a JPEG and convert it to a raw image. You're not going to do a design in a raw file format because raw images are strictly unprocessed data that comes out of a camera or a scanner sometimes, but rarely are we going to encounter that kind of thing. So a raw photo or a raw image is just data straight from the camera sensor. It's not processed yet. It's not rendered out into pixels. It can't be used for pixel-based editing as a result. So when you open a raw file in Photoshop, it doesn't open it right in Photoshop. It goes into Adobe Camera Raw first, which is a raw processing, a raw conversion engine. Lightroom is the same thing. Capture One Pro is another one. There's a bunch of other programs out there that do this sort of thing. But you have to edit a raw file using a parametric editor because all you're doing when you're editing a raw file is you're setting up a batch of instructions that say to do these things and then create some pixels that look like this. Hopefully that makes sense to you. You've got to try it out a little bit to have it make sense, but there's in your tech project a chance to do that. So a couple of things to be aware of with raw images. I started writing this out as kind of a pros and cons list comparing the two, but it turned into just some ideas. So one thing is that raw images are grayscale. If you don't know how camera sensor works, again, that's in 384. I'm not getting into it too much here, but it's grayscale values. If you want an idea of this, just look at your channels panel in Photoshop at a color image, and you'll see those channels broken out, red, green, and blue, or cyan, magenta, yellow, and so on. Those channels are each grayscale, but Photoshop knows that one represents red, and one represents green, and one represents blue. That's kind of what happens with the information that's in a raw file. The raw processing software develops that by demosaicing that pattern of red, green, and blue. It's not quite like that because the pattern is different over a camera sensor. Again, I get off topic on camera stuff a lot. But anyways, it's grayscale. It's just brightness values. And different colors are applied to those brightness values to create a full color image. But the raw file itself doesn't have color assigned to it yet. And that isn't a negative against it. That's actually a positive. Color isn't set. It's not baked in at that point, so it can be modified to a great extent without degrading image quality, which is a big deal for editing, post-processing. One thing that is kind of a negative about raw files is that they are typically proprietary, meaning the manufacturer of the camera is going to set up the raw file in a certain way, and they're not going to share that information and make it open source for different vendors and software companies and things like that to deal with and edit. Adobe does a pretty good job of reverse engineering a lot of that and decoding those files so that you can edit them in Lightroom or Camera Raw or whatever else. But they are proprietary. So if you shoot with a Nikon, you'll notice that the raw files come out as a .nef. A Canon is a .cr2 or CRW. Sony, Pentax, and whatever other camera manufacturer, they all have their own raw formats too. That can be potentially a problem down the road. Let's say that Nikon goes out of business and nobody supports that file format anymore. You might have a hard time opening files from an older camera if that's the case. Adobe came in and decided that they were going to create an open source format called DNG. .dng is the extension. It stands for digital negative. And that is an open source raw file format. So when you shoot your Nikon raw files, you can actually convert it to a DNG. And there's a couple of benefits to that. One, is that file format itself allows for the metadata to be embedded. It doesn't use a sidecar XMP file, so you don't have to worry about shuffling things around in your hard drive and losing all your work. Also, it's open source, so even if Adobe disappeared someday, all the standards and instructions for that file format are in the wild, they're open source, and any manufacturer or software company could develop software based on that standard. Okay, so definitely some pluses as far as this. Now looking at the right-hand side, so maximum image quality is a feature of raw images because there's no compression whatsoever. You don't have any artifacts from compression. No color information or luminance information is thrown away. You have high bit depth, and so that allows you to have greater dynamic range. The image I showed you before, that glass pyramid, that's at the Louvre in Paris. That was actually a raw file where bringing up the shadows, bringing down the highlights, adjusting the exposure allows you to get all the dynamic range that's in that file and take advantage of it. If that were shot as a JPEG and I tried to brighten up those shadows, I wouldn't get the detail and color quality that I get from a raw file. That's what high bit depth does for you. All adjustments are non-destructive. We talked about this before with parametric editing, but that's a big plus with raw images is that you're not going to mess the file up. You're not going to damage it. Whatever you do is just simply a set of metadata instructions that can be modified at any time. The nice thing about those instructions is that they're similar to a recipe. And if you come up with a recipe you like, it's really easy to reuse it. You can copy those adjustments to multiple files in a batch or whatever. Typically, if you're shooting an event, let's say you're an event photographer, whatever kind, you go to the ASU Inferno Fest concert coming up here in a week or so, and you shoot that concert and you come home with, I don't know, maybe 1,000 photos or 800 photos or something crazy like that. And you use the wrong white balance for all of them. That's going to be a major pain if you did that as JPEGs, in addition to a lot of other reasons you wouldn't want to do that. But with a raw file, you can just change the white balance on one or select them all and change on all of them at the same time. And the color that comes from your white balance setting in your camera isn't going to mess the file up at all. You're not doing any kind of destructive editing. You're simply changing the way that color is interpreted based on that original grayscale luminance values in those 3 color channels. Anyway, that's a lot of information. I hope it's not overkill. Hopefully you guys learned a little bit from this and didn't come up with too many new questions, but also I hope that you do have some questions that spur you to look into it a little bit more and find out about it. Try out Camera Raw. I highly recommend it. In Photoshop, there is a Camera Raw filter since one of the CC, I don't know, probably 2015 or earlier than that probably. But anyways, Adobe Camera Raw filter can be used on any type of layer within Photoshop. Now, if you remember what we talked about last time with non-destructive editing and smart filters, you can make sure that you convert that layer to a smart object before you use the Camera Raw filter, and then it's non-destructive when it applies it. So that you can come back in and you can modify those settings and change them or copy them and paste them or whatever. So try it out. Play with the Camera Raw filter in Photoshop on individual layers or on groups or however you want to. And then see if you can get a hold of some raw images to just play around with in Camera Raw editing in general. It's a very powerful application that lets you do a lot of things. I shoot a lot of photos personally. I'm a huge photo nerd and I do it professionally on the side too occasionally. And I strictly stay in RAW on my camera. I never take it out of RAW, and I always shoot RAW photos, and I always develop them in a RAW processing engine like Lightroom or Capture One. And there's just so many benefits to it. It doesn't make sense to shoot JPEG if you have the ability and you don't mind the extra hard drive space that it takes up.